There's a planet close enough to the Sun that its daytime surface hits temperatures hot enough to melt lead. And yet NASA has confirmed that same planet is quietly hiding water ice, sitting frozen and undisturbed in permanent darkness less than 1,000 miles from some of the hottest ground anywhere in the solar system. That planet is Mercury, and it turns out to be one of the strangest, most contradictory worlds humanity has ever studied up close. Despite being the closest planet to the Sun, and despite being visible to the naked eye since ancient times, Mercury remains one of the least explored rocky planets in our entire solar system, and everything NASA has managed to learn about it has come from remarkably few missions, each one uncovering something scientists genuinely didn't expect to find. Stick around, because some of what's hiding on Mercury's surface is stranger than anything found on Mars or Venus. And if you want to catch every new discovery as a brand new mission finally arrives there, go ahead and hit follow before we get into it. Mercury has a strange reputation among the planets. It's the smallest planet in the solar system, barely larger than Earth's own moon, and yet it packs in a massive iron core that makes up roughly 85% of its entire radius, an outsized core for a planet its size that scientists are still working to fully explain. Its surface bakes at temperatures exceeding 800 degrees Fahrenheit on the sunlit side, while plunging to nearly 290 degrees below zero in the shadows, one of the most extreme day-to-night temperature swings of any planet in our solar system. And despite sitting right next door to Earth in cosmic terms, Mercury has only ever been visited by 2 NASA spacecraft in the entire history of space exploration. The first was Mariner 10, which flew past Mercury 3 times back in 1974 and 1975, providing humanity's very first close-up images of the planet. Mariner 10 mapped just under half of Mercury's surface, revealing a heavily cratered world covered in ridges and smooth plains, broadly resembling Earth's moon at first glance. It also detected something scientists genuinely didn't expect to find on a planet this small, a real measurable internal magnetic field. Most planetary scientists at the time assumed a planet as small as Mercury would have cooled and solidified deep inside long ago, extinguishing whatever molten core dynamics are needed to generate a magnetic field in the first place. Mariner 10 proved that assumption wrong, and that single discovery kept scientists puzzling over Mercury's interior for decades afterward. It took more than 3 decades before NASA sent anything else to Mercury, this time an orbiter named MESSENGER, an acronym for Mercury Surface, Space Environment, Geochemistry, and Ranging. Launched in 2004, MESSENGER didn't actually enter orbit around Mercury until March of 2011, following a lengthy series of flybys designed to gradually adjust its trajectory using the gravity of Earth, Venus, and Mercury itself. Once it finally settled into orbit, MESSENGER spent more than 4 years studying the planet in detail, becoming the first spacecraft ever to orbit Mercury. And it fundamentally rewrote what scientists thought they knew about this small, scorched world. One of MESSENGER's most striking discoveries involves something that seemed almost impossible given Mercury's extreme proximity to the Sun water ice. Because Mercury's rotational axis is tilted by less than 1 degree, almost perfectly upright compared to its orbit, certain craters near its poles never receive any direct sunlight at all, staying locked in permanent shadow no matter how the planet rotates. Scientists had actually suspected something like this might exist since the early 1990s, when Earth-based radar observations bounced off Mercury's poles and returned unusually bright reflections, hinting at the possible presence of ice long before any spacecraft could confirm it directly. MESSENGER finally provided that confirmation in 2012, using 3 independent lines of evidence gathered by its instruments, including direct measurements of hydrogen concentrations using its neutron spectrometer, reflectance measurements from its laser altimeter, and detailed thermal models built using the spacecraft's own topographic data of the polar regions. What MESSENGER found was genuinely striking. In the very coldest of these permanently shadowed craters, water ice sits exposed directly on the surface. In slightly warmer craters, where surface temperatures are just a touch too high for ice to remain stable out in the open, that same ice survives, buried just a few tens of centimeters beneath a layer of unusually dark material, insulated from the small amount of residual warmth reaching those craters indirectly. Researchers estimate these polar deposits contain up to 1 trillion tons of water ice in total, an almost unbelievable quantity of frozen water sitting on the single hottest planet, on average, in our entire solar system. According to MESSENGER's principal investigator, Sean Solomon, scientists believe this water most likely arrived on Mercury the same way it's thought to have arrived. On Earth, delivered gradually over billions of years by impacts from comets and volatile-rich asteroids slamming into the planet's surface. That dark material covering the buried ice deposits turned out to be its own separate mystery. Researchers determined it's likely a mixture of complex organic compounds, delivered to Mercury by the same kinds of comet and asteroid impacts responsible for the water ice itself, essentially acting as a natural insulating blanket that helps protect the ice underneath from the planet's otherwise brutal surface conditions. Messenger also stumbled across a completely different kind of surface feature that nobody had ever seen anywhere else in the solar system. Small, irregular, shallow depressions that mission scientists eventually named hollows. Unlike craters, which form from impacts, hollows appear to form through a completely different process, one tied to Mercury's unusual surface chemistry. Researchers studying high-resolution images from Messenger's final, lowest altitude orbits found that these hollows have unusually sharp, well-defined edges and very few small, young impact craters marring their surfaces, both signs that they're geologically quite young and may even still be actively forming today. The leading explanation involves a sulfur compound present in Mercury's surface material that appears to be slowly destroyed and lost directly to space in the specific locations where hollows form, essentially eating away at the ground itself in a process unlike anything documented on any other planet. Beyond these surface mysteries, Messenger also revealed some genuinely strange things happening deep inside Mercury. Detailed measurements confirm that the planet's magnetic field, the same field first hinted at by Mariner 10 decades earlier, is oddly offset, with its point of origin sitting roughly 20% of Mercury's radius away from the planet's actual geometric center, an unusual imbalance scientists still don't fully understand. Messenger's data also showed that Mercury has been quietly shrinking over billions of years, as its interior gradually cools and contracts, with the planet's radius decreasing by as much as several kilometers over its long geological history, a process that has left long, curved cliff-like features called scarps etched across its surface. High-resolution imaging near the end of Messenger's mission even revealed smaller versions of these scarps, more than 10 times smaller than any previously identified, suggesting some of this slow planetary shrinkage might genuinely still be happening in the present day. Messenger's mission finally came to an end on April 30th, 2015, when the spacecraft, having run low on fuel, was deliberately allowed to spiral downward and crash directly into Mercury's surface at roughly 8,700 miles per hour, a controlled ending that let scientists gather data right up until the very last possible moment. For nearly a decade afterward, humanity had no active spacecraft studying Mercury directly at all, relying entirely on the archived data Messenger had left behind. That gap is finally about to close. A joint mission between the European Space Agency and the Japan Aerospace Exploration Agency, called BepiColombo, launched all the way back in October of 2018, and after a journey spanning more than 7 years and 6 separate gravity-assist flybys of Mercury itself, it's scheduled to finally enter orbit around the planet in late 2026. BepiColombo actually consists of 2 separate science orbiters traveling together, the European-built Mercury Planetary Orbiter and the Japanese-built Mercury Magnetospheric Orbiter, designed to work in tandem and provide a far more complete picture of Mercury than any single spacecraft could manage on its own. Each of BepiColombo's 6 flybys along the way has already returned valuable new data and close-up images, including detailed views deep into permanently shadowed polar craters and unexpected variations in the particle environment surrounding the planet's magnetosphere, hinting that the space environment around Mercury is even more dynamic and variable than scientists previously assumed. Once BepiColombo finally settles into its full science orbit, it's expected to carry a significantly more advanced suite of instruments than Messenger ever had access to, including a specialized infrared spectrometer designed to map Mercury's surface mineralogy in detail for the very first time, something that could finally help settle a long-standing scientific debate over exactly how Mercury originally formed. Competing theories range from a violent giant impact early in the solar system's history, similar to the collision believed to have formed Earth's own moon, to a process involving intense solar vaporization that may have stripped away much of Mercury's original outer layers. The 2 orbiters working together are also expected to produce the first true 3-dimensional model of Mercury's magnetic field and magnetosphere, finally combining detailed measurements from both hemispheres in a way no earlier mission has been able to achieve. Taken together, everything NASA and its international partners have learned about Mercury so far paints a picture of a genuinely contradictory little world, the closest planet to the Sun, and yet home to confirmed water ice, one of the smallest planets in the solar system, and yet built around one of the largest cores relative to its overall size. A surface that appears ancient and heavily cratered at first glance, yet still actively shrinking and reshaping itself even today. Every mission that's ever visited Mercury has come away having overturned some prior assumption about what a small, scorched planet sitting this close to its star should actually look like. If a story like this, a planet hot enough to melt lead, quietly hiding 1 trillion tons of water ice in its shadows, is the kind of thing that genuinely fascinates you, go ahead and subscribe, drop a comment. letting me know what you think BepiColombo will find once it finally settles into orbit, and stick around, because Mercury is about to get its closest, most detailed look in over a decade,